Hello, my name is Dr. Copa, and in this video we're going to be looking at the Grignard reaction experiment. So we're going to start with part A, which deals with making the Grignard reagent. So for that we're going to need magnesium turnings. So I have already pre-weighed about 0.3 grams of magnesium turnings in this round bottom flask. On top of that round bottom flask we have this Clayson head. So the Clayson head has this vertical tube. And it has this side arm that points upward. And on that side arm, we have placed a drying tube that we have inserted through a thermometer adapter. So the drying tube looks like this. So this is the drying tube, and it's inside or it's on top of this thermometer adapter from a distillation setup. The drying tube has a cotton plug, and on top of that cotton plug, we have placed Dry-Rite. So Dry-Rite is simply calcium sulfate. Dry-Rite often has these indicator pellets that come in normally a blue color, and that shows you, or that tells you that the Dry-Rite is fairly dry. It can absorb water. When it starts to turn sort of a purplish color, that's a sign that it has absorbed a lot of water, and you might want to change the Dry-Rite at that point since it's no longer effective. So the point of this is to maintain sort of an outlet if any pressure builds up in our system. So we're going to be heating this reaction, so we always want to have an escape for that pressure. But by having this drying tube on that sidearm, we prevent water from coming into our reaction and destroying the Grignard reagent. So on the Clayson head, we have placed also a septum on this part of it. So a septum looks like this. So it comes sometimes in red or sort of beige color, and it can come in all different sizes. This particular one fits nicely into the glassware we're using. So you will want to place it over the opening that you want to seal, and then bend the septum down and cover that hole. So inside of this round bottom flask, as I mentioned, we have magnesium turnings. So there they are, sort of little specks of magnesium. The smaller the magnesium is, the more effective they're going to be in this reaction, since it'll provide more surface area. The shinier they are, that's also a good sign. So when it starts to sort of turn to a grayish color, that's a sign that it's reacting. Magnesium has reacted with air and produced magnesium sulfate on the coating or on the outside of the magnesium strips. So that's going to sort of slow down the reaction. We want to have sort of the shiniest possible magnesium turnings we can use for the reaction to be quick. So after you have added the magnesium turnings, next step is to add a stir bar. So here is the stir bar we're going to be using, very small one. So stir bars come in different sizes. So for our purposes, we can use this little one. And the point of a stir bar is to stir the reaction. So if we drop it into our reaction and it got stuck here on the Clayson head, we're going to have to turn this over. If we drop it into our round bottom flask, when we have it in the round bottom flask and it's sitting on top of a stirrer, like this one, which is also serves the purpose of a hot plate, by turning on the stirring motion on this hot plate, we can stir the reaction. So next step would be to add a little bit of the bromobenzene. So that's our other reagent in this reaction to make the Grignard reagent. So for that, we have placed 1 milliliter of bromobenzene in this round bottom flask, along with 5 milliliters of ether. We're going to take a small amount of this solution, so about 1 ml. And we're going to add that to our reaction. So at this point, it's probably a good idea actually to cap our reaction. So we can do that with the septum. And we can use our needle, pierce the septum, and then slowly add our bromobenzene mixed in with ether to the magnesium turnings. Okay, so next up, we want to turn up the heat on the hot plate. So you actually don't need much heat. The point of the heat in this experiment is to speed up the reaction. Since the solvent in this reaction is ether, it has a very low boiling point, right around 35, where we want to heat it to. We want to make sure that we don't heat it too much above that, otherwise the ether will very quickly evaporate. That's going to occur in this experiment because the experiment tends to be slow, so that's one of the sort of things that I'll caution you about this experiment, is that it often takes 20 to 30 minutes to form the Grignard reagent, so it's sort of a test of patience. You're going to have to constantly maintain the heating on this reaction, and very often you're going to have to sort of add more ether. So for that, we have about 5 milliliters of ether on an Erlenmeyer flask. We'll use a different syringe to replace the solvent that evaporates from this reaction as the reaction progresses. Hopefully within 30 minutes or so, we'll get a reaction. This a good sign that you have the reaction has started is when the reactions bubbles on its own. So if you remove it from the heat source, if you see bubbles in the reaction, that's a good sign that it's reacting. Since the Grignard reaction to form the Grignard reagent, I should say, is an exothermic reaction. And another sign is that this reaction, which currently is colorless, the actual liquid inside of the reaction is colorless or clear. If it turns a brownish color, that's also a good sign that the reaction has started.